Well, this is Old Electronics Fan, and on the bench today, I have a Pilot tuner, little FM receiver. It's not a radio; it's just the receiver. Um, and this is the second one that I've gotten. The guy I knew was downsizing, and he gave me a price for this that I couldn't turn down. So I said, "Why not?" It's in pretty good shape. The plastic panel is fallen in, and it's yellow a little bit, but that's pretty typical for these. I might try polishing it, see if that will come out a little bit, but if not, it'll be okay. The one thing that this didn't have is the original knobs. The Pilot tuners had fancy knobs that had kind of a nautical emblem on the knobs. So this was somebody had lost the knobs and found something else, and so it's not original, but the other one I had, somebody had refinished it, and they did a pretty lousy job. This one looks like it's the original finish, and let's get this out of the way. I don't need you in my way right now. And it's got a label on top. I'll have to get that off. But the back cover is good. The cord seems okay. This is probably an older model. Mine actually has an RCA jack on the back that will allow you just to plug in an RCA cable. This one has just the wire connections. This I believe is for the antenna. On mine, I think it had a little part that swiveled. That seems also to have disappeared. And also the other interesting thing about this is that it's set up so that you can, remember this was designed to provide FM for radios that were built without FM. Because FM finally came along, and there were a lot of radios out there that had a phono input, but they didn't have an FM provision for an FM of any kind. So when these came out, because you only had one input into your, because the radios were mono, you had one input into your radio for the phono. So what do? Well, you could keep swapping back and forth between the two items. Kind of a pain. Or, let me see, where is this? Do they have? Oh yeah. Okay. They have instructions in here on how to. So this is a printout. Somebody scanned an actual manual, and they're explaining to you how to connect your phono connection to this. And they talk about high and low, and you could tell which one is which by touching one of these. So early phonos, apparently they had screw terminals, not this style. But anyway, get into that later. But anyway, so the to make that a short story, when you have this off, the phono, the turntable can play through the radio. You turn this on, this plays through the phono input, and you don't have to swap anything around. So, and they have instructions on the back how to use that. The built-in antenna, permanent. Ooh, wait a minute. Through the wire link. Okay. All right. So they tell you, explain how to use that antenna setup. I can't remember. I could look at it, but what I'm going to do right now is I'm going to just pop this cover off, the back cover, and yes, some of the screws are missing, and I'll use this, throw those in there. and the screws are not all the same. So this little radio's been around a lot, and different people have had their digits in it, unfortunately. But surprisingly, this still exists in some very nice shape. Okay, tubes are still there. It's got 5 tubes in it, I think. This is one of the antenna. Alright, so I guess the next thing I want to do is pull the knobs off. This one here. Then, what do we got in the bottom? We got nothing on the bottom. So there's supposed to be screws on the bottom, and those seem to be gone. Alright, oh, we have a label on the bottom here. What's this? Model T601A. I can't remember what mine was. This is the tube burst. Oops. 25 watts. Well, since we're doing that, let's do that. Alright. Okay, put that over here, out of the way. Take a peek underneath. Let's try to get some light on here. I feel like I need to come up with better lighting, but now this cord, I'm looking at this cord right here, and it seems fairly healthy. Alright, so looking inside, the electrolytic has been changed, it looks like. Just judging from the soldering I see going on. What is this? Trying to see what that says on there. Where are you? That looks like a little capacitor. Yeah. Fairly high value. What are you? Ohmite. Okay, that's a resistor. So we have a resistor here, a little capacitor here. What are you? Oh yes, I remember this. I believe this is a paper capacitor trying to look like a mica. I'm pretty sure that's not. Well, it looks like that capacitor may have been replaced, but if it has, it's leaking. See the wax melting off from it. Oh yes, somebody has definitely been in here. Let me show you. I guess I'm not the only one who used that trick. Let's try to put some more light on here if I can. That is a piece of solder wick, and I don't remember what was there on mine, but interesting. So somebody has had their little digits in here. That can be good and that can be bad. This has been sitting so long, I'm pretty sure there's no voltage on that capacitor. I'm just curious, let's back this up. You're not seeing anything, are you? Sorry about that. And let's see, this says I should probably see what it says for real instead of what I think it should be. 20, 40, 40. And let's see. Alright, so the 20 is the D shape. Okay. Alright, so this is a transformer set. not a series string, which is kind of nice. Alright, so this one should be the 20. Let's find out what kind of ESR it's got. So 22. Well, that's one. What is this? 400, 350, 350. Which goes off the scale. Here, do I have a chart? Okay, yes. So, 1.1 or 1.5. All right. So the 20 is 400 and 400. Somewhere between 1.1 and 1.5. Because they don't give you that exact. So let's see. So check this out. Okay, so that tests out okay as far as ESR. Let's go to this one. That's fine. And that one's fine. Whoops. So the ESR appears to be just ducky. Now I don't know who replaced this. Yeah, that's really healthy. I don't know who replaced this, but they put new wires in. That looks new. And so chances are this is pretty good. Interesting. Okay. Now this is an older diode, but it appears to be. It's. Let me think. Oh, this did have. Oh, yes, I'm pretty sure it did. Diode. Where are you? Oh, yeah. All right. So, if you look at this right here, and you see a bunch of diodes, it's not unusual for selenium rectifiers to be designated that way because each section is a diode section. I guess they just stack them together according to how much they need. I guess I have never really checked into that. So somebody's already put a new diode in here. Now the concern I have is I don't see a resistor. Let's see. Well, let's take a peek in here because I want to. So let's go back to this for a minute. This is why you check things out first before you start digging in. So there's the transformer out, goes into the rectifier. Okay, oh, so it is across these two. Okay. Aha. Alright. It's supposed to be a 2 watt 470, and it should be higher than that because selenium rectifiers have higher internal resistance, so there's lower voltage coming out of them than the newer diodes, and so the voltage coming out of that's going to be higher, and this means this resistor has to change. And so what have they put in here? 510. I don't think that's enough. Do they? I wonder if. Let's see. I have to look and see. I'm looking to see if I have because I've worked on one of these before, and I might have a printout of the information for this, and I'm wondering if that includes a schematic with the voltages, which would be kind of nice. Okay, where are you? If I don't have it here, I probably have it in a PDF somewhere. Which means I'll have to kill the camera for a minute and go find it there. Let's see. Oh, here it is. I do have a printout of this. I'm glad I started getting a little bit more organized. So let's take a peek at this and see if I have something with voltages. Ratio. Okay, there is something on the back here. Aha. So there must have been somewhere a chart that told me what the voltages should be. And I do have voltages written in. Okay. So, let's see. Kind of wish I had a voltage down here for the B plus coming off from that. I don't see that written in anywhere. No. Let's travel over here, see if I have any numbers that help me out. So typically the plate voltages are between 94 and 92 and 98, I thought I saw. Alright, so that gives me a quick, I can just figure out which tubes are where, and we will measure. Alright, so, let's see here. I should probably make sure the right tubes are in the right place. Although, knowing the guy that I got this from, they probably are. Looks like a 6AL5. This should be a diode. Okay, where are you? 6AL5, yep. So, and that does go there, I seem to recall that. Let's see, 5. Yeah, and some of these, as you can see, not so hot. You can kind of make them out. Ratio detector, number 5, it's that one, 6AL5. Let's try, I want to see the one that has the highest volts on it, which is a 6BE6. 6BE6, which is pin tube, or tube number 2, and it's that one. And the display on this is kind of nice, so. Alright, so 6BE6 on pin 5 is going to be, we hope, 98 volts. So, okay, that should be on. Pin 6. So let's make life easier on myself, and I'm going to, and it looks like everything goes to chassis. Yeah. If you look at the transformer, it's connected directly, well, it says chassis. The symbol is chassis, and I don't see anything else, because there can be two symbols for your ground. One could be chassis, and one could be your B minus. And let's go here, take a peek, transformer is there. Well, actually, this tells me what I want to know right here. Metal case, grounded. Everything's grounded to that. This is grounded. So that's what we're going to use. Alright. And just for the fun of it, we can watch the voltage come up. I hook onto it. So I believe, so 1, 2, 3, 4, 5, 6. Uh-oh. Ew. Yeah, I think we're going to measure that resistor. That looks like it got torched. 1, 2, 3, 4, 5, 6. And so let's check that out first. There's a little resistor that comes off from pin 6. I don't know where it goes yet, but I don't like how it looks. And it looks like this line comes over here, goes to this pin, and then feeds. Oh yeah, I do remember. Alright, well let's just find out. I'm going to check both of them on here. I'm going to wind up checking the resistors anyway, see how bad they are. That one looks like it's been torched. Alright, so alright, so we go here. 1.1K, and what are you supposed to be? Looks like it's supposed to be a 1K, and this was the same, so yeah, that's 1K. They both are. Yeah. Well, all right. The resistor doesn't appear to have been fried, so yeah, I think actually are the two tubes that have 98 volts. I think they both are fed from yes, or 70, but there should be. I'll look for that later. Alright, so I'm going to plug that in here. That is on. Let's bypass it on. I'm going to. So what I'm doing over here is this is one of the things I liked about this. The reason I designed this the way I did was I have switches that controls which bulbs are used. This is only 25 watt draw. That's what it's rated for. So this should be my lowest watt bulb. This is my next highest, and that's my highest. I didn't label it. I probably should have, because with my memory, it's probably a good idea. So anyway, I'm going to zoom out a little bit, and I'm going to turn this down a little bit there, and pilot light doesn't look like it's survived. We'll see. Well, let me just quickly check first. I haven't done this. I'm assuming that everything is well. But let's see if come on. I'm going to check and see if it's shorted. I don't expect it to be. Nothing says that it should be. 91. Definitely not shorted. It's a transformer set. Of course, transformers have gone bad before now. Is there anything else I want to check? Well, I'll find out in a minute when that light bulb lights up and doesn't go out, if something bad is going on. Alright, so this should give me the plate voltage for Okay, that's oh, that's right. I like to see where my output is, even though I've got a mark on there. Okay, so that's climbing up. Let's get up to 60. My bulb isn't lighting. I didn't really expect it to. I don't know what that actually is. 29 watt. It's a 40 watt equivalent. That's what they started doing. Of course, getting incandescent lamps of any kind now, you can't buy them locally. Okay, so let's go up. Still nothing there. We got 1 volt. But I should start seeing more volts because now, oh yes, my pilot light has come on. I probably should just took a look at this to see. That's awfully low. 5.5 volts. Huh. Oh, yeah, that shouldn't be. Let's go up to 100. Yeah, that's not right. And I'm starting to see a glow coming from my bulb. I was saying I've only got 70 volts there. Why? Oh, probably because of the bulb. Alright, let's crank this up. That might be what's going on. Yeah, I probably have... Oh, you know what? I goofed. Alright, let's go back here. Let's go back up there. That explains a lot. I had it connected in the wrong place. Ah, there we go. That's more like it. Alright. So, that's just... Now, some people called me on the carpet because I called this, what did I call it? Extreme Poor Man's Variac. That's what it was, Extreme Poor Man's Variac. Now, I'm going to show you something, because this explains why, one of the reasons why I called it that. Let's zip in there. Right now it's saying 97 volts. Now what happens when I go do this? It drops down to 74. Now if I go up here to this one, now it's 98, 104. As you change the resistance that you're putting in the circuit, it changes the voltage that's available to the device you have connected to it. So, yeah, and if I go here, so you get a couple of steps of voltage. You know, you start off with, what was it down here? 73 volts, and then I was at 94, and then it went to 100. So, like I said, poor man's Variac. I like it because I can control the combination of bulbs that I'm using, and I can control, even without using my variable transformer, I can control the overall voltage. So I think that light is on, the pilot light is on, that is on lightly. If I go here, the light goes out. So now what I'm going to do is I'm going to do that, and now we're up to full voltage, and that's too high. So I'm going to kill that, because that's not good. I don't believe that's correct. I'm trying to remember where I got those voltages from. Give me a moment and I will see if I have a chart that tells me such things. Oh, come on. Yeah, I don't remember where I got those voltages from. It's been too long. So let's take a peek. Oh, there we are. Okay. I'm sorry, I didn't, as always, remember to back out. Okay, I do have a chart. And if you go to, this is where those voltages came from. And 98 is what it's supposed to be, 94, 94, 92. Well, actually that's probably one's the plate, one's the screen grid. I was getting 90 at that point, apparently. This one was 92 instead of 94. Ratio detector. That's basic. This is just a diode, so that might be why. Oh yeah, AC. So, so at that point, by the ratio detector, you're actually sending an FM signal, an audio signal out to the amplifier that you're using. So that's AC out. All right, so that is why, that's where those voltages came from. So, now I have to figure out what I want in there for a resistor. Now, I do have it. I probably didn't write it down, did I? No, I did not. Yeah, so I really don't like that. I think that's way too high. And not recommended. So, so they've got that resistor. This resistor here is a resistor they put in. It's supposed to be 2 watts. I don't know if that is or not. Oh my. Here's the part number. Can't tell. It doesn't say on it. Sometimes they do. This time no. Trying to think. I suppose I could do it the Ohm's law way, or I could cheat and look at my other pilot. Do I want to go through all that trouble? Maybe not. Alright, so but the first thing I want to do is turn my soldering iron on, and yeah, this is you know, I kind of thought this was going to be relatively straightforward. This may actually work as is, but I'm not real excited by I'm not really excited by what I'm seeing, so we're going to do something here. Let's see. Do I have, let's look here. I'm digging through some stuff here so I can move something around. I don't want that there. And cheat. See if I can do it this way. I should probably see what the voltage is at this point. I didn't measure that. I should have, but I did not. Because that will tell me what I want to know. Yeah, I want to know what the voltage is. So let's put this back up and run this back there. Oh, let's see what it's telling you. This tells me 0.25 is what I think that is. Yeah, about 1/4 of an amp. That's what that's saying. Now let's check it here. See if they agree. Saying 25 watts. This is 0.3 amps. So that one's ever so slightly above 1/4. Alright, so we'll calculate it based on 0.3 amps. And alright, well I decided I want to do this just a little quickie trial and error. Basically I'm using resistors that I have to start with. So I decided, well, I've got these, it's quick and easy just to switch them in. So, and so the voltage is dropping down as it starts conducting. And I have 600 volt ohms here, and I'm still about 10 volts off. I was guessing off the top of my head that I probably want about 800 ohms. Let's find out. It probably means I'm going to have to get an 800 ohm. So I don't think I have. So this is going to be a 200. So that should give me what I want. Alright, let's go back up there, see how we do. Come on, you can do it. Really? Well, do I have a 1K somewhere? That might be what I wind up with. That's close. 102 is definitely close. Let's go to this. So, there's a 1K. Let's find out if that's what we need. And okay, this is 10 watts, so it's overkill, but hey, if it works, that's all I need. And there it is, 1K. Oh, slightly under. Now, I have a feeling that the actual voltage I'm getting to this is lower than it's supposed to be. Ooh, that was kind of noisy. So let's see, where can I get voltage for this from this? Oh dear. Okay, so there's one side of my AC and there's the other side. Okay, so let's find out. That's very close. It's almost 120. The kilowatt is telling me 114.6, it lies. So let's just, I have a little mark on the face of this transformer, variable transformer. And there it is. So when I have my little white line aimed right at my mark, that's right dead on. And so now I'm at 95 volts, which is actually slightly lower. So, okay. It might affect performance a little bit, but actually the other thing I want to look at is, so I'm think. So filament voltage. Okay, so this is important, definitely. But I want to look at filament voltage, and because I don't know how much this is going to get used if I sell it on, which I probably will. But I'm assuming these tubes with a 6 in the front of their name are all 6.3s. And so, 3, okay. So I'm on, well, let's see, this one's 3 and 4. Let's get you off from here. And it should be AC volts, so let's switch this back. And so let's see, pins 3 and 4. 1, 2, 3 and 4. .5. Huh, okay. Now I have learned that different tubes can wind up with different voltage on them, even when getting supplied by the same source. Let's see. So, those are also 4 and 3. What we got here? 1, 2, 3, 4. Is that right? Let's find out. .5. Interesting. So my plate voltage is slightly low, but my filament voltage is a couple of volts higher. So let's see. Let's check this one out. They're all the same voltage. Interesting. Well, that's... Oh, I didn't notice this. Somebody put a new little capacitor down there. Interesting. The filament voltage coming from the transformer is slightly high. I think there shouldn't be, yeah. Oh, yeah. So there's our filament winding. There's our pilot light, which is across this, and that seems kind of bright, but maybe that's normal. And it says this is a 6 to 8 volt pilot light. Well, I'm less than thrilled by the slightly higher plate voltage, but where I'm putting, okay. So actually, let's do something. Let's go down here to 117. I'm curious. there's a method to my madness. I'll tell you what it is in a minute, if it bears fruit. Let's see here. 1, 2, 3. Let's go up here. 1, 2, 3. All right, let's try this. .5 still. All right, so I move this down to around 117. Oh, didn't change that much. There's 117 more or less. 6.4. I believe the voltages of the power that was being provided to homes back when this was made was somewhere around 117. And now that I've got it down to 117, pretty sure that's what I got it to. Yeah, more or less. So now that I've got it down there, yeah, and the closer I get it to 117, the closer I get it to 6.3. Yep. Let's go back here. 116. Okay. So this it's kind of warm. Slightly high. Let's just for the fun of it. Let's take this out, and this string is 800 ohms, and I'm going to add a 100. There it is. So I'll just throw that on there. So now I should measure it to see if it really is that. So I'm sure the resistors aren't all exact, but okay. Let's bring this back up there. Since it's going to be running around that, I mean the only way to get the filament voltage down where I'd like it to be would be to add a buck transformer to this, and there's no room in it to do that. Or you put a high watt resistor in the circuit to try to drop the overall voltage. Again, that's not great either. So let's go back here to, oh, well, let's try it. Yeah, let's try this. That's right. Definitely not thinking. Alright, so 900 ohms is almost exactly what we want. I had a 1K on there before, so it's 97.5, which is very close. So will the extra 100 ohms make that much of a difference? It did. I think it was 96 volts. Alright, I'm going to go even crazier. Do I have, that's 750. I don't know what the wattage is on that, but we'll try it anyway. So I'm going to do, this is a 750, supposedly. Okay. Oh, no. Why did you turn it off on me? Apparently the battery went bye-bye. That's one thing I like about the old Beckman. I could run this thing forever, and batteries just last. Alright. That's close enough. 750. Okay. And that's 200. Okay. I'm going to move that off my mat just in case it gets really warm. Now, this. Alright, so we go up here. And we're going to go to here. And we'll start there. I think it goes up above that. I think. Or not. It doesn't matter. Shouldn't matter. Okay. So I now have 950 ohms on there. That's not too bad. So I have that resistor in series with it. But the current should be the same for both. Alright, so 950 ohms would work. So I don't have one of those. So what I might do temporarily is just put the 1K ohm resistor in there. And then go from there. Now, yeah, got those for there. Alright, so the next thing I want to do though is hook up, stop it, since I don't know if this actually works, I'm going to that wasn't too bad. Too bad 750 wasn't what I needed. I have a resistor for that. We're going to use the 1K ohm. I think it'll be close enough, and I don't think it's going to hurt the performance that much. It's going to be very close. Yeah, I can just probably get that in there somewhere maybe. Once I have this mounted in place, once I have this mounted in place, I will come back and I'll have this hooked up properly, and then we'll listen and see if we've got an FM receiver or not. I am going to get rid of all the paper. I am going to check this guy here. I think this might be a cross-the-line cap. That's what I think that is. Actually, now that I think about it. Yeah, I'm pretty sure that is. 10 picofarads. Yeah. I think this is. It goes from the line cord to chassis, and And I think that's that big black thing that's stuck in there. Pretty sure it is. It's 0.01. Alright. Okay, so I'll get that mounted in there, and I will get this all hooked up so that when I come back we can check and see if we have FM working on that. The last, I don't know if it's the Fidelitone, the Fidelo tuner, and I don't know if that one was not too bad as far as the alignment, but the other 601 that I worked on, somebody definitely had their little golden screwdriver in there playing with it. So that was less than ideal. Alright, so I've got this hooked up into my little amp down here. I have my resistor in there. If I haven't screwed anything up, I can throw my light bulb on. Oh, it's still on. Ooh. Oh, it's a bypass. Alright. Just to make sure I didn't screw anything up, I can turn my light bulb on. And that's all happy. So, okay, well, I don't have anything. Well, there's a real given that people have put marks on these. That definitely leaves me wondering if they played with that. But I'm going to try something else. Yeah, we have nothing. I should have something from that. Oh, wait a minute. Okay. You can't probably hear this. I got my amp maxed. This little amp is capable of, it's 35 watts, so it's capable of a lot of power. So, yeah. So we have something going on. So it's possible that make sure I'm pretty sure I have that hooked up correctly. Yeah, pins 4 and 5. 4 is the ground, 5 is the hot side. There are a couple of possibilities. One is that one of these capacitors is doing bad things. This one looks like it's been sweating. So what I think I'm going to do, what I think I'm going to do is, well, I should probably check because he's replaced this, and the soldering work is not exciting to me. It looks like he was soldering on a budget, whoever did this. They were not, they were, or I think, a little bit stingy when it came to solder. But what I think I might do is, after I check that out, and this, there is assuming a picofarad level capacitor should mean that says 40 picofarads and that's 47, it looks like. Oh, wait a minute, that's microfade, go ahead. Where is, 0.005 picofarad, and that goes to ground, yeah, okay. Alright, so that is, so this is a 0.005 picofarad, and it looks like that's probably the right one he put in there. Okay. Let's find input. FM output. Oh, really? Oh, I goofed. Okay. Alright, there may be nothing wrong with this. Yeah. Yeah, I think these are yes, knucklehead. Okay. Let me see if I can figure this out from here. Yeah, okay. Well, it's amazing we got anything out of it, because I was doing the wrong thing. I was reading that. What this is for, it says it right here, phono input. So what they're doing is the phono input from your radio actually from your phonograph, the record player, goes here. This is FM out. So when you're not, yeah, think brain. Okay, 6 is ground, 7 is the FM output. So when you want to listen to your FM receiver, you turn the unit on, this switch moves from here to here, and now you can listen to your receiver, your tuner, through the phono input. Which this, they call this phono input, but this is the input from the record player. So when this unit is off, this switch goes to here, and now your phono comes in here, goes here, and this goes back to the phono input on your radio. Well, I have a feeling this will work a whole lot better if you wire it up correctly. Let's see, yeah, get ready to go. Wow. Okay. And the fact that I was getting something through it is nothing short of amazing. Oh well. I got so used to the other one being so convenient. You just plug the yeah, brain, I think, the phono connection from the radio into the phono jack on your pilot, and then you would hook your phono over here, and all will be well. So this should work a whole lot better. Alright. Okay. So turn that down, it's down. this on. Okay. Oh boy. The mistakes I make. I don't know if I have any use for those. Let's throw them there.
No. A sense of wonder.
There it is.
These students will pass along to their own grandkids. Now, they're not from the Andrea Lorian. I love that. It's 4:46 and you're listening to All Things Considered.
This is not performing well. Oh, it doesn't have an antenna. That would explain a lot. That would explain an awful lot. Let's try that. Yeah.
Back to the Brandon. The home opener for the Yankees after the 6-1 start. Now it's emptied out. Not a fan to be found after the Yankees 3-0 loss to the Blue Jays. The Verizon Yankees postgame show rolls on. Emmanuel Berbari with you. Yankees did get the tie. Medical consultation to determine the ED medication.
Friends, you've listened to us over the air and online.
Yeah, that works better.
And Venus below. In the south, look.
They're concerned about the consequences they could face, but they say.
Yeah, it's working fairly well.
Camille Phillips.
Now, curious. Let's just for the fun of it. What I believe they do internally from this. So, let me explain this for a minute. This is the connection for the antenna right here. It goes to the tuning condenser, capacitor. This is a connection, I believe, through a little capacitor, and they're using the power cord as the antenna, and it's not all that unusual. If you've worked with vintage stuff at all, stereo stuff, you will have found that sometimes the power cord comes over and there's a little metal clip that's wrapped around the wire, and that goes into your antenna connection, and that acts as your FM antenna on those radios. So, yeah.
Still outside, looking on towards Monday. Next day, forecast, it's mostly sunny.
All right, I thought I was getting something down here. So let's check that out again.
It's 4:49.
Let's try this again. And it's been my experience that the antenna provided internally never works as well as.
Sing Muslims.
Oh yeah, huge improvement.
On to sunset.
5:50. It's 4:50. WAMC Regional News is coming up at 5.
So, just having this wire on there instead of it goes up there. I got looped around, so it would stay up there. So that makes a big difference in the reception. So this is actually working very well. I can't remember how this compares to the other one that I worked on. And I am going to do more to this, and it depends on how it performs, whether I do an alignment or not. I have done it before and it has made a big difference. So what I'll probably do, just for the fun of it, what I'll probably do is, once I get the bad capacitors out of this, then I'll check the resistors and all that sort of thing. And it's possible, and I need to order that. I need to check on that, see what that is. But that tells me whatever this is, it's fine. I don't hear any noise. It's not creating any problems. But I will, when I pull the other radio out, other tuner out, I will look at that and see what they use there. But anyway, back to this. And it's hot, but not terrible. 2.2. So I'm gonna go through. I'm going to check all of the resistors. Alright, so I shall return when I have this work done. Well, this is why I've been starting my pattern of replacing things a little bit at a time. I know a lot of people, myself included, I used to just go through and replace everything I'm going to replace. But I ran into a problem where apparently I made a mistake or something. I'm still trying to sort that out. So what I've been doing is I replace a section a section at a time, and so right here you'll see that I replace this. So I replace this capacitor and these two resistors. These are out of spec. And actually that's as far as I got. But when I brought this up to see how it was working, I got nothing.
Officials in Ulster, Orange, Dutchess, Putnam, and Rockland
Tube socket, it seems. Now I've wiggled these tubes before, but
no damage has been reported so far.
it didn't seem to misbehave.
It's throughout the state of New York that is critically important.
So I'm assuming I have a dirty tube socket. So what I'm going to do is I'm going to pop this out. And it doesn't look terrible. I ran into problems with a Pilot before. It was this tube over here, and it just did not want to. I spent I don't know how much time trying to get that to work again, and it turned out that it really was just a dirty tube socket. But yeah, that was a lot of fun trying to figure out what was wrong with that. In addition to the bad solder joint that I made, something I've been very aware of since. So let's see, did that make things work better? Go to that too? Huh. Nope. Huh. That's not good. Weird. Wait.
Lake George Length and really on the fabric of this interview.
Vinny Presido is the Lake George Deputy Town Supervisor. Like many in tight-knit Lake George, Presido...
I may have a bad switch.
I worked with Dennis for so many years. He was
You know what?
He did so many things so well. He bridged the gap between our environmental issues and our business, the growth of business in our community. And not only was he a great supervisor, he was a great friend. I'm going to miss him.
Dickinson first served as town supervisor between 1979 and 1982 and began his second stint as supervisor in 2012. Warren County Administrator John Taplin said while he knew the Republican was sick, Dickinson's death came as a surprise.
Everyone is shocked in the county.
In addition to serving as town
Well,
supervisor, Dickinson meeting on April 19th. Taplin said Dickinson promoted the Adirondack summer getaway as a destination even in the off-season. And that was one of
So,
kind of his favorite topics to discuss.
well, it seems like it's working now. Definitely going to shoot that, see if that's my culprit. Two. This tube was definitely misbehaving. Doesn't seem to be anymore. But this, on the other hand, does seem to be giving me fits. And let's get that off from there for a minute. And well, the camera, I thought was acting up. That's all I need. Well, let's just try this one more time before I continue on with my repair work. So this tube I had soldered new components onto that. So I double checked that solder joint. Everything looks good. I checked here and here because I replaced a number of items. So I had a solder joint here, which I actually took my heavy duty solder iron and heated the entire thing. That's what got me in trouble last time. I only got the tip of the connection soldered and the other part failed. This one, that one. All of those connections I double checked and tried to make sure that it was that everything was good. Trying to avoid making that mistake twice.
On Marketplace at 6:30.
Support comes from the Berkshire Health System, line of community service connecting patient options weekdays 8 a.m. 855-855-2000. WAMC regional weather summary with meteorologist.
Okay, so that seems to be working fine. So, I still got a lot to do. So far I've checked, how many did I check? This one, this one, this one, this one. I think I did that one. Let's double make sure. But so I've had to replace 2 out of those few that I've checked. This one actually is coming in very close to what it's supposed to be. So I'm not going to replace that one. Let's see here. Yeah, so anyway, kind of surprised at having so much fun already. I thought, oh man, I did another bad solder joint, but thankfully no.